So, hi guys. Now we are starting with unit 2. So, in previous unit, we saw some basic introduction on C++ and OOP, like encapsulation, data abstraction, data hiding, etc. So, now we'll be starting from constructors, types of constructors, then destructors, then about this pointer, friend functions, and we'll study a main concept called inheritance, and then we'll see all the other things. So, first, we'll start with constructors and destructors. So what are constructors and what are destructors? So constructors and destructors are basically the member functions of a class. So firstly, if we take a constructor, they are the member function of a class, which will be created or initialized as soon as an object is created for that class. So in simple words, we can say it like it is a member function which will be initialized on its own whenever an object of that class is created. So it is simply said to be, it is mainly used for object initialization of some values, but it also has various other purposes. Same for destructors. Whenever an object is destroyed, a destructor will be called, which means objects will be sent out of scope. And the main point to remember is that all constructors and destructors are public member functions. But still in some scenarios or in very rare cases, we'll be using it in private member functions as well. But majorly we'll use it as public member functions only. So other main things to remember is that there is no return type, which is a major point to be noted. And then the name of the constructor is same as the class name. So you'll get a clear idea when we see some examples. So getting into types of constructors, there are three main types: default constructors, parameterized constructors, and copy constructors. So we'll be seeing each of them in detail. So in default constructors, like there will be no parameters or arguments passed, and the required operations will be performed. While in the case of parameterized constructors, the objects which are being created will be given with parameters, such that those parameters will enter these constructors and such values will be assigned. Then copy constructors. Why are copy constructors used? Assume you have two objects and both of the objects have most of the properties or features to be the same, and only one or two data members are changing. So we can just copy on object A to object B and thus change only the required values. That is the main use of copy constructors, and we'll be seeing the syntax of these in detail. So default constructors generated by default is no constructors are defined, called when objects are created with no arguments. Similarly, parameterized constructors are created with arguments, and copy constructors. So there is basically two main types of copy constructors. One is shallow copy and one is deep copy. So always a better method would be a deep copy method. So what is a shallow copy? So assume you have two objects and a data member and two objects A and B, and a data member of A is said to be in an address like 1000, you keep it. Now when you do copy constructor using shallow copy, that address will be copied such that both the objects will point to the same address in the same data. So whenever the data of one object is changed, obviously the other data will also change in other object, which is actually not feasible. There comes the solution of deep copy. In the case of deep copy, the copy of the address will be given to the object B as well. So new memory will be created and that address will be given. So whenever object A is changed, there won't be any changes in B and vice versa as well. So seeing with types of destructors, this is a default destructor where we won't pass any parameters. So this is basically used for initializing the values like width is equals to 1, height is equals to 1. In the case of other major problems, we will be giving it like unknown, 0, etc. Now in the case of parameterized constructors, this is basically a form of setter functions as well. So we'll get the values in the main function, we'll be assigning it with the data members. Now comes the copy constructor where we'll pass the call by reference of the object itself such that this width will be the width of object B, which is equals to other. Other is the object A, which is being passed into this copy constructor. Other dot width and height is equals to other dot width. This ensures both the values will be same. Next is a destructor, which is used to clean up dynamic resources if any. And now these can be called in the main functions in this format. So rectangle R1 in the sense it is default. Then 5, 3, this will go as integer values, and R3 is equals to R2, which is a copy of R3 is a copy of R2 rectangle. So you can just refer this table as well. So that's it about constructors and destructors. We'll be seeing it more detail during inheritance as well. Now, so as of now, are there any doubts?
No, no.
Okay, then we'll go to our next topic, which is a this pointer and friend functions and friend class. So this pointer is most basically a simple topic where it is actually a hidden pointer, which is mainly used in the cases where the parameters passed has the same name of that of the data members. So in our subject, we'll use this pointer only in this case where the parameters passed are the same as that of the data members. So when we are passing the parameters in the same name, so assume you're just giving roll number is equals to roll number and name is equals to name. This obviously causes error in the a compile time error in the program. So we'll use this pointer where this means the roll number of this object and name of this object. So for every object, this constructor will be created, and for that, every data members will be putting this keyword such that it points to this object. So this sentence means roll number of this object is equals to roll number which is passed here. That is the main role of this pointer, which is used in object-oriented programming. So when to use members and local parameters have the same name. So like roll number is equals to roll number is confusing. Like roll number of this object is equals to the parameter roll number. So this seems to be more clear. Now method chaining is also a part of this pointer only, which can be solved using this pointer. Next, we'll move on to friend function. So what is a friend function? A friend function is usually declared in a class, but it is defined outside the class, such that it is non-member function. So this function does not belong to the class itself, but it is only declared as a friend to that class. The main syntax includes friend keyword before the return type. So as I said before, it is declared within a class, but it is defined outside a class like a normal function. So what is the main purpose of this friend function is that even though it does not belong to the class, it has the ability to access the private members of the class which it is a friend of. I'll explain with the example, like it can access private and protected members of a class using objects of the class. So we know that any function can access a public data members. But what about private and protected? That we'll be seeing in detail as derived and base classes. But before that, there's a concept called friend function, where this function can access the private and protected members of the class which it is a friend of. So assume this example, like we have bank account and in account number and double balance. And we have this constructor where we are giving the parameters to be included. Now we have this friend function. Like this is the syntax. We use the friend keyword and then we declare it like a normal function. Void display account, and the main syntax again here is that we'll be passing the object of this class, the bank account class. So the two things to remember in a friend function or a friend class will be, we must use this friend keyword in the beginning, and we'll pass an object of the class it is friend of, as a parameter to make this friend function work. And now the definition of the friend function can be made outside the class, like void display account, and then back account ampersand account. And then as you can see here, the private members of this class is accessed in this friend function in the form of the object name dot the data type or whichever data member is needed. Account dot account number and balance is equals to account dot balance endl. So this is how a friend function works. What about a friend class? Friend class also works in a similar way, where it is declared inside a class and defined outside the class as well. And an example for that include, assume that we have a bank account, same example, and also we have the same constructor. Now we are giving friend class bank manager. So we are creating a friend class called bank manager to this class bank account, so that the class bank manager does not completely belong to this class bank account, but can access the private members of this bank account. So you may think like, what is the actual use of this in day-to-day programs, but this actually has a lot of uses. So in this example, like as usual as in friend function, we can just void print account details, and we'll be, as I said, we'll be passing the object as a parameter and we'll be taking the value. So this is basically about friend class and friend function. So as of now, any doubts, guys, do you have?
Nope.
Okay, then we'll move to inheritance. So what is inheritance? Inheritance in normal terms or in scientific terms means that gaining some characteristics or features from someone, as a child gains or inherits some features of parents. So that is the basic idea of inheritance. Inheritance of traits or characters. So what is inheritance in OOPS? So as you assume like you have two objects, A and B, and most of the characteristics of both the objects are same. Then instead of typing two different classes in two different types in long codes, we can create a single class common for A and B and include in it all the common characteristics of both the objects A and B, and make these objects A and B as derived classes for that base class. So that works as the major background for inheritance. So take this example. What is common between assume object A is rectangle and object B is cuboid. So between these two, what are the common characteristics? It includes length and breadth. So we'll be having a base class which has length and breadth, and a rectangle and cuboid will be derived class as well, or rectangle can be kept as the base class and cuboid can be made the derived class for the rectangle, because every rectangle would be a cuboid, right? Or we can say in terms of like all the cuboids are made of rectangles. So a rectangle contains length and breadth, and a cuboid contains length, breadth, and height. So the characteristics of a cuboid, length, breadth, and height, in which length and breadth is contained by this rectangle. So we say it in that way. Instead of two separate classes with separate data members and member functions, we use the concept of inheritance to reduce redundancy. And that becomes the main motivation for inheritance. So inheritance includes a base class and a derived class, where the derived class inherits all the characteristics and features of the base class. So the other names includes parent class and superclass. While for derived class, it will be child class and subclass as well. In the example we took, the base class will be rectangle class as I said, and derived class will be the cuboid class. So the cuboid inherits data members, length and breadth, and member functions of the rectangular class. So in the type of access specifiers, apart from private and public, we are seeing a new term called as protected access specifier. So what does this mean? So protected access specifier involves all the data members and member functions that will be accessible only to that class and the derived classes of that class. So basically what is private access specifier? It is only accessible to that class. What is public access specifier? The private members, the public members are accessible to all the classes as well as the main function. What about protected access specifiers? It is accessible to that class, which is the base class, and also to all the derived classes of that base class. So you'll get it more when we see more examples. So this is a base class rectangle. This is a constructor for initializing the values. This is a parameterized constructor where we are assigning the length and breadth of the rectangle. And this is a simple function for getting the area and displaying the area. So this is a simple program with a base class. Now assume we are creating a new class cuboid such that it is derived class of the rectangle, and the syntax would be like this. Class, the class name of the derived class, colon, and then this becomes the type of inheritance which we are doing, which we'll be covering later in the session. And then this is the name of the base class. So here we'll be giving the new parameter which is not present in rectangle here, which is not common feature. And then we are getting the values, we are calculating the volume, and we are just printing it. So this is the main concept of inheritance. And we'll be using this in this way in the main function. We'll see more examples in next slides. So coming to the types of inheritances. This is the same example. Okay, so there are three main types of inheritances. One is public inheritance, one is private inheritance, and the third one will be protected inheritance. So assume we have a base class and we have these public members, protected members, and private members. And these are the types of inheritances which we do. This is public inheritance, protected inheritance, and private inheritance. First, let's go with the private member which is present in the base class. So what is the basic thing do we know? A private member is only accessible to that class and not to any other classes as well. So a private member of a base class is not accessible in derived. It is not accessible in derived and not accessible in derived in all the three cases. So a private member will only be accessible to the base class and it cannot be accessed in derived even if we inherit in all the three forms. So this is as simple as that. A private member is only accessible to the base class and it cannot be derived. Next comes, let's go with a public member. So what is a public member? A public member of a class can be accessed by all the other classes and also the main function. But here in this case, it depends on the type of inheritance which we do. So this word, the word which we put after the colon mainly determines the type of inheritance. That is, the values which are derived from the base class in which access specifier those will come into. So for example, we have a public data member and in the class derived, we are doing public inheritance, which means the public member of the base class will come under public in the derived class. Now let's take a public member in the base class. And now we are doing protected inheritance. So a public member in base class will come as a protected member in derived class. Now let's take for private inheritance. A public member in base class will come as a private member in derived class. So even though a data member is public, it can be made to access differently in different classes, that is the derived classes in a different way, using the types of inheritances. Now let's go to protected member, and this also works in the same way. If we do public inheritance, so the maximum thing this can be done is protected. So even though we do public inheritance, this remains protected in derived. Now protected member, when derived as protected inheritance, this remains protected in derived. And then protected member, when derived using private inheritance, this becomes private in derived. So basically, this is all about inheritance access on base class members. So we'll get more idea when we solve more problems on this. But this table is said to be very important, and understanding this is a major concept in inheritance. And these inheritance types are said to be more simple. So single inheritance, multi-level, hierarchical, and hybrid. So what is single inheritance? We have a single base class and we have a single derived class. And a single inheritance from a base class to derived class. A vehicle to car is called single inheritance. What is multiple inheritance? We have two base classes and one derived class. So this type of inheritance is called as multiple inheritance, where two parents and one child will be there. Next, we move on to multi-level inheritance. Multi-level inheritance include a tri-level system of inheritance as well. So like vehicle, like car inherits from vehicle and sports car inherits from car. So we can say all sports cars are car and all the cars are vehicle. So this is it works in this form. Next, hierarchical. Hierarchical inheritance include a single base class and two derived classes as well. Assume we have the vehicle as a base class, the derived class 1 will be car and derived class 2 will be truck. And finally, hybrid inheritance, which is basically a combination of the other two of other inheritance or more, like two or more of other four inheritances. It can basically be in this form. And now comes diamond problem. So what is a diamond problem? Which mainly occurs in hybrid inheritance. So see, this base class has two derived classes, derived 1 and derived 2, which is hierarchical inheritance. And now these two derived classes gives derived 3, forming a multiple inheritance here, making overall hybrid inheritance. The major problem which occurs is that assume we have a function called display or something here in the base class. And when we call it, and then assume in the main function we are creating an object for the derived class 3. And from this third derived class, we are calling the display function from the base class. So assume if there is no derived 2 class, the display function from the base class would come to derived 1, to derived 3, and then to the main function. But since there are two derived classes, we get a compile time error, like the compiler doesn't know which route to take. Hope you guys understand this. So the major solution which we use is that we use a virtual keyword, such that we use virtual public inheritance, which ensures only one copy of all the common data members and member functions are created from the base class, such that when they are called using the derived class, only one copy comes without any error. So as we got in our MSc examination, one answer or one solution would be to use the virtual inheritance or the virtual keyword. And the second type of solution would be to use the scope resolution operator, such that we'll explicitly mention you come via this route. That is, you come via derived 1 or come via derived 2. So these are the two major solutions we use for a diamond problem. Moving on to next, UML class diagram for inheritance. So as we saw in Unit 1, Unified Modeling Language is mainly used to represent the code or program to solve a problem more easily and efficiently. So this is a simple UML diagram for a diamond problem. As I said, the diamond problem, the main solutions include the virtual keyword. This is what the syntax would look like virtual public inheritance and virtual public inheritance. And now getting into the UML class diagrams of inheritances. So the main concept here is a basic example of what we saw in the unit 1. So this includes private members, which has the negative sign, and public members has the positive, plus symbol. And a simple UML diagram of a class include the class name and then data members and then member functions here. These are the access specifiers, these are the names, and these are the data types and return types as well. This is the parameter which is being passed. Now, what about in the case of inheritance? This is also a basic example. Yes. So assume this is a simple code for inheritance, a class bank account, and we also have a savings account, where the savings account will inherit the characteristics from the bank account class. So the UML diagram will look like this. Class name, the data members and member functions. And then the derived class savings account, interest rate, and then the member functions of these. So this relationship is said to be known as is a relationship, such that we can say it in a way all the derived classes is a base class, such that all savings account are bank account. So how to identify if a given thing is an inheritance or not, if a given relationship? We can try to think it in a way all derived classes are base classes. All savings account is a bank account. If this condition is not satisfied, then this is not an inheritance. So in always inheritance works in the policy of is a relationship. These are some examples which you can try by yourself. Okay, now we'll move on to constructors and destructors. So since we work with inheritance, there are different ways in which the constructors and destructors will be called during the inheritance which we use. So these are the basic introduction which we saw. Okay, let's take this simple example. Like we have a class base and we have a class derived. We also have a constructor, a base class constructor and derived class constructor. So thinking about which will be called first and which will be called second. So this will be the output. So always remember for constructor, the base class will be called first and derived class will be called later. And for destructor, it will be the opposite way. The derived destructor will be called first and base destructor will be called at last. So what this means is that whenever an object is created for a derived class, firstly, an object of a base is created, which includes the object of the derived. So that is what this actually means, like base constructor and derived constructor. And first, the derived object is being destroyed, and only then the base object is being destroyed. So it always follows this order. So this seems to be quite easy, but if we think in different types of inheritance, it will be a bit confusing. These are examples with parameterized constructors, which also give the same out. Base constructor, derived destructor, base destructor. Now let's take this example. We have a base class grand and we have derived class parent, and then this is not a hierarchical inheritance, it is a multi-level inheritance. And then we have a child which is inherited from parent. So what will be the order of the constructor and destructors? It will be like this. First will be the first base class, then the middle derived class 1, and then of the derived class 2. And then the destructors will be in the opposite way. So yeah, this we have seen. Okay, now let's consider this diamond problem where we have grand as the base class, and then we have parent A and parent B, which is the derived classes of grand, and then we have a single child that is the second derived class or the last derived class of parent A and parent B. And we also have different constructors to be called. So in which order will these constructors will be called? So as usual, the base class constructor, grand constructor will be called first. Then the class with parent A, the constructor of that will be called, and then of the parent B will be called. So the top part of the diamond problem, which is usually a hierarchical inheritance, firstly the base class will be called, and then the class which is being created first, or the object which is being created first will be called, continued by the second object. So always it will be grand, and then the first derived class, and then the second derived class for hierarchical inheritance. Now forget the top part and come to the below part where we have two base classes and one derived class. In that case, the order of constructors will be called in such a way that in which order we are inheriting those base classes. So in this case, we are inheriting parent A first and then parent B. So in this case, the constructor will be called in the order of A constructor, B constructor, and then the child constructor. So assume we have parent B and parent A here. Then parent B will be called first, A will be called second, and then the child constructor will be called. And always remember, the order of destructor being called is exactly opposite of the calling of the constructor. So in this case, it would be grand constructor, then A, then B, and then child. And the destructor would be the exact opposite. So now coming to the final part, where we have two main keywords, static keyword and const keyword. So like I want to know, like, are there any doubts till now to you guys?
No, no doubts.
Okay. So after completing this, like we'll see a code which has all the characteristics of this, and then we'll have a short quiz. So I want all of you guys to stay till the end. So coming to the static keyword, what does the static keyword mean? Static keyword usually belongs to a class itself.